In this video, we're going now to interpret our skewness and kurtosis on our histogram based on the computed values. Now, before we go through, remember that we have seen skewness and kurtosis computed already in our table before. So as you might have remembered, we have here kurtosis and skewness as part of our numerical. This is our numerical data description table. Data description table. So we have our kurtosis and skewness. Let's review first their values. Remember, if our skewness is greater than 0, then we have a positively skewed. Oops, sorry. Let's erase that. There you go. Let's change that to positively skewed. There you go. Positively skewed, which means we have more lower values. And we also have skewness equal to 0, meaning our distribution or our data set is symmetric. And if we have our skewness as less than 0, then we have a negatively skewed data set, which we have more high values. So, based on this one, let's see our skewness value here. Our skewness value, Sk, is equal to 1.74, rounded off to 2 decimal places, which are greater than 0, which means, based on the value, our data has more lower values. So, now, let's take a look at our histogram to prove that. Let me just clean that up. Alright, so, we can see that the middle of the distribution is probably somewhere around here. And as you can see, more of the values are actually here, on this side. So, it somehow corresponds to our ideal picture that more of the values are actually on the lower side, or we have more lower values, which are here. So therefore, consistent with our skewness value, we can say that this distribution is positively skewed. Or another way of saying it, skewed to the right. And that's how we do skewness. How about kurtosis? So first, let's review our kurtosis. So if our kurtosis value k, let's write it here, kurtosis value k, wait a moment, let's start here instead. If our kurtosis value k is greater than 0, we say that our dataset is leptokurtic, which would mean we have more extreme, very high or very low, very small values. If k is equal to 0, then we have mesokurtic, which means our distribution is symmetric. And if k is less than 0, then we have platykurtic, which would mean that we have few or less extreme, which means very high or very low, very large or very small values. So, let's take a look. Our kurtosis here is actually 6.05. Let's write it here. Our kurtosis is 6.05, which is greater than 0, which means the given is leptokurtic. We have more extreme values. And let's take a look at the histogram to verify that. There you go. So, our tails are usually here at the lower ends. And as you can see, if this is our middle portion or somewhere around here, just like in skewness, we have actually more lower values, which are these. So let's make it into a box. So these are extreme values. Moreover, we also have data here, which are also extreme values. So if I am going to erase, I'm going to erase the middle one. and I'm going only to box this here, we can see that we have more actually. We have more extreme values, either very small or very big extreme values. And this is consistent to our kurtosis value, which says our data is leptokurtic, which has more extreme values. And that is how we interpret skewness and kurtosis with the help of our histogram.